All right. So I want you all to take a minute and think about everything that the internet enables us to do. The billions of people we can connect with, the sheer wealth of knowledge that we have access to, all the goods and services you can buy from around the world. Doesn't it seem inconceivable that in the early 90s, people thought the internet was just for email? Send a message here and there. I think it is just as inconceivable that the blockchain is only for cryptocurrencies. So I'm Jack Saba. I'm the CEO of Ledger Atlas, and we're working on bringing the blockchain and its investment opportunities into emerging markets. So today, I'm going to talk to you about Bitcoin, because that's where it all started. And that's going to allow us to dive into the blockchain, the life cycle of startups, just to understand where the technology is at, the use cases, and then initial coin offerings. If you have questions at all during this presentation, please stop and ask me. I think everyone else is going to have very similar questions, so just be brave enough to ask and we'll dive in a little deeper. So the first problem that the blockchain solved, that Bitcoin solved, was the need to reconcile transactions between institutions. So right now, I'm from New Hampshire. I have a small bank account in New Hampshire. If I wanted to send money to my co-founder down in Papua New Guinea, it has to go from my small bank to a big bank to an international intermediary to a big local bank to a small bank in his country. Each one of those institutions has its own ledger. The process has to go from my bank to the next one, and then they have to agree that that transaction happened. It takes about a day. Then it goes to the next one, and they have to agree that that happened. And this takes time. It costs money. It's inefficient. So Bitcoin's solution was one ledger, shared across all databases. And so now, instead of having to have this process of reconciliation, the network, the Bitcoin's network, looks to see that my account exists, I have accrued enough value, that my friend's account exists, and then the transaction's facilitated. So the way that we have one ledger living on all databases is that it grows chronologically. So from the start of Bitcoin, when it first started, to where we are now, blocks are added around in 10-minute increments. So every transaction that happens within that period of time is grouped together and then added to the blockchain. What that allows for is all computers on the network to agree on everything that's happened up until now. So ledgers lived in all these different databases. People had different sets of information, and you had to reconcile it. Now Bitcoin comes along, one ledger across all computers on the network, and the network validates the transactions. So this is an example of how the blockchain grows chronologically. So a block existed, and then all these transactions happened around a similar time. They're grouped together again, they're grouped together again, and then a piece of information from the previous block is linked to it. It's represented in a long string of numbers like this. And all these computers on the network guess at what that next number is going to be, and the first computer that guesses it correctly adds the block, and new Bitcoin are created. You guys with me so far? Any questions?
Can you just repeat what you
Yeah. All of it, or? Yeah. Yeah. So transactions that happen at the same time are grouped together. So you send money to him, I send money to you, you send money to him. Those transactions are grouped together, and then they're grouped together again. And then they take a piece of information from a block that came before it to make sure that this is a unique piece of information. So you have to link it to the one before it. Then that's represented in a really long number, and computers guess at what that number is. The first computer to guess correctly adds the block, and then they're rewarded with Bitcoin. Yes?
So basically, all blocks just keep adding information as you start creating them until the previous blocks, right?
Yeah, so it grows chronologically. So it goes 1, 2, 3, and then 4, and it just continues to grow that way. And so that way, if, say we added information on block 4, and then around block 7 or 8, you tried to say, go back, hold on, he didn't send me $50, he sent me $500. Like, he tried to change that piece of information. Since all the computers on the network already agreed that it happened, you can't change it. Yeah?
While all miners are trying to guess that number, who knows what that number is during that process?
It's randomly generated. So it's a hashing algorithm, so the information's randomly generated ahead of time. Was there a question over here? Yeah.
It's just who states what is correct? So how do you know that it gets it correct?
The rest of the network, yeah. So everyone saw the transactions happen, right? So we all agree that these things have happened, but then you just get it right, and then it gets added to the blockchain. You had a question over here?
I was wondering, so all the, for example, all the transactions happening right now stored together into block 10.
Yep.
For example. But does it have like a limit in?
How much information?
Yeah.
Yeah. And so that's a really big issue with the technology right now that we'll get into later. There's more transactions happening than the network can update at that time. And so it's a scaling issue, but we'll get to that in a little bit. Any other? Yeah.
So does each computer have the whole history of the blocks?
Yes.
And at what point does it become way too much or a memory issue?
So there's billions of dollars in value on the blockchain. Bitcoin's been around live since 2009. The entire network is only 71 gigabytes. So what they're doing in this process right here is taking a lot of information and condensing it into just small representations of the information and then putting it on the chain. Yeah?
Can you repeat the part you said about 10 minutes, every 10 minutes?
Yeah, so in order to ensure that there is security and that nothing slips through the cracks so that you can't send one token to me and him at the same time, the network needs time to validate the transaction. So hard-coded into it is that blocks are only added once every 10 minutes. And that slows down the transaction time, but it provides security.
So up to this minute, every 10 minutes there's a new block added.
Yes. And so
Every 10 minutes.
every 10 minutes. And so what happened is in the early days, you could do this mining thing on your laptop. It was like that's the only amount of computing power. But then people started to make so much money, they started to, maybe I'll use a supercomputer, and then maybe I'll get a warehouse of those, and then I'm gonna have a whole facility of those. And so as the computing power increases, the difficulty of guessing this number increases to ensure that it only happens once every 10 minutes. So that 10-minute interval is a security measure in order to ensure that people aren't manipulating the network. Yeah.
So are these numbers still, because I know we started with prime numbers, are these still advanced prime numbers, or are they no longer prime?
I got to get back to you on that. That's a great question. No one's asked me that. You stumped me. I'm going to keep moving we'll do one more question, then we're going to keep moving.
So what if like after 10 minutes there's no one that get a number right? So there's no block to be generated?
So the block maybe would happen like at 11 minutes or 12 minutes. And if that was too difficult, the network would adjust the difficulty of getting it so that it comes back to about 10 minutes.
And it happens in 2 weeks, right?
What do you mean?
Each 2 weeks they're recalculating the
Yeah.
difficulty.
All right, so Bitcoin. So that's the blockchain, right? So really difficult when when information's living in different places, it's really difficult for everyone to agree on what's happened. So Bitcoin came along and they said, let's put all the same information on all the same computers so that we can agree on what's happening. There will only ever be 21 million Bitcoin, which means that the price of Bitcoin is dictated by supply and demand. It's like gold. There's only so much of it, so based on what's out there and what people are willing to pay, it finds its price.
Will that number ever go up?
21 million? No. Not unless the entire network agreed on it. But they're divisible down to like 10,000 places, so it's like you can spend very small amounts of the currency. Yeah.
Is it supposed to be the entire network or like 51%?
To update it, it would be 51%. So we'll get into that. It's a really good question, but a little more advanced than most people right now. Yeah.
Why that's limited?
Why is it limited? Because that's what they decided ahead of time. Because they wanted to be a fix for traditional currency. And if you look at a country such as Venezuela, sorry if anyone's from there, but if you look at a country such as Venezuela, their economic policies allow for them to continue to print money, just constantly print money. They all have that, and they fundamentally disagree with that. And so they said, we're going to put a limit on it, so make it a commodity like gold, so that the price is discovered by supply and demand, and it can't be manipulated by a central authority.
But in that situation, the price will always go up.
Not necessarily. If demand decreases, then the price will decrease.
But if it is limited and if the demand just stays like that, when it has ended, the price will dramatically increase, right?
If demand increases, if the supply is fixed, which it's almost always fixed because it's on small intervals, right? It allows for a price to be discovered. So it's not like it's just going to immediately take off out of nowhere. It'll only take off like that if the demand increases.
What if demand increases?
then the price increases, and then you spend fewer Bitcoin. So if right now it costs me 1 Bitcoin to buy a gallon of milk, and then the price of it greatly increases, it's only going to cost me a third of a Bitcoin to buy a gallon of milk. So you just find that price discovery.
You know how you gave the example of gold. Like in the very future, when if everybody goes into cryptocurrencies, wouldn't this be kind of in essence going back to the gold standard?
Yeah, very much so.
Where you can't do quantitative easing and all that kind of stuff.
Yeah.
And problems associated with that, perhaps.
Possibly, but with each new innovation becomes new solutions, right? So like the same issues that existed with gold don't necessarily exist with a digital version of it.